So should I start sharing my screen, Pete, or?
1 second here.
Okay.
I'll start the recording. And I would say yes. Go ahead, John. It's 11:59. If you want to wait just a second before you actually start the discussion, but if you want to share your screen, you can go ahead.
Which one is it? Hey, wait a minute.
Should be called Desktop 1.
Okay.
That'll share your whole screen, not just the.
That's what I really want. Okay, great.
Yeah.
Desktop
Otherwise,
one.
if you just share an application, if you start in a different application, it's not included.
Yeah, that's kind of a pain, actually.
I think that happened with Matt when he was doing the seminar where he was sharing his PowerPoint and then he wanted to share a bunch of images and it was a different thing.
Yeah. Okay, I guess I'll get started. We're past noon. Is that okay?
Yep, I'd say go ahead.
All right. Welcome to our weekly weather discussion. Here we are on another beautiful sunny Friday. I think it's been a nearly unmitigated string of gorgeous weather. I'll make a comment about that in a minute. And I'm going to let this weekly satellite image animate in the background. It won't be the focus of the discussion for the current weather, although there are many elements in it that are worthy of attention. So this goes from last week's weather watch right up till about now, or maybe an hour or so shy of now. And you can see it's been a pretty stormy period across North America and adjacent waters, one after another type of disturbance in many different scales. I'll point out a couple as we go. I guess we'll wait till the beginning of the movie again. Here we go. Last week, there's a giant cyclone over maritime Canada at that time, and then this little leaf that came past the southeastern states. We had a beautiful weekend, and especially beautiful early part of the week. And then it started to get stormy again on the western part of the continent. So here was storm number one emerging from sort of the subtropics, boundary of the subtropics, and then this pinwheel of convective clouds, which will become the major event for Colorado and Wyoming into the coming weekend. And then there's that storm that kind of somehow escaped attention, skirting across the country and ended up in the same place as the one that started the week. So it's been really quite stormy. Watch in the Atlantic in a moment here. We're going to be on about Monday morning now. That's a pretty decent storm that goes racing up into the North Atlantic. Then there's going to be a couple of smaller scale disturbances in here. Here's one of them, really small scale. And then there's a storm that gets itself wrapped up for us, cold front tracing back. And there's the next storm in its wake. I just want to say a few things as you watch that a little bit more. You can, first of all, this time of year, you can really see, since it's an infrared image, you can see the land get hot and then get gray again. So it gets really dark and then really gray, and that's the diurnal cycle. And it testifies to just how much sunshine we've had in so much of the country over the last week. On the 22nd of February here in Madison, we had a 16-inch snow cover, which represented the season's maximum. And everybody remembers February. We were 10.2 degrees below normal or something like that. And we had a lot of snow, and it kept on piling up because it never melted. So we had 16 inches of snow cover on the 22nd. Officially on March 10th, Wednesday, Madison reported 0 snow cover. So we lost 16 inches of snow in 16 days. And that was an inch per day on average. And that's just an incredible streak of unmitigated rapid melt. I don't know what the record is for most rapid decrease of snow depth, but I would not be surprised if this is close to it in the long historical record here at Madison. Over that same period of time, from February 22nd to March 10th, we averaged 6.2 degrees above normal. And there were only 3 days in that period, March 1st and 2nd and the 4th, where the average temperature was barely below the climatological average. So it was, as I say, an unmitigated, uninterrupted stretch of not only warmth, but abundant sunshine. So much of the snow was probably sublimated, not so much melted, because there's not much puddling around after losing 16 inches of snow cover in a short period of time. So pretty darn remarkable. And, it doesn't have to be like this. March, especially the second and into the third week of March, historically has been a really stormy period. You can think about the storm of the century from 93, the great blizzard of 88 in New York City. There was a famous blizzard in the Dakotas and Minnesota in 1941 in this period. The first time the word blizzard was ever used to describe a snowstorm was in Iowa's Esterville Indicator on March 14th, 1880. And so, this is a time of year where things can be pretty wild and remain wintry, but that has not been the case for us so far. Things are about to change from that perspective in the plains of Colorado and Wyoming and maybe western Nebraska and Kansas. So that's going to be an interesting forecast issue. It's only beginning to take shape now, so it'll only be a little pepper to my discussion, my part of the discussion this morning. Okay, so let's go next to, I want to go to a slower version and a more proximate in time version of our infrared satellite movie. So this is just the last several hours. And so it's slowed down a little bit. You can see there's our big storm in maritime Canada. The cold front trailing from that goes across the middle Atlantic states, then across the Ohio River Valley, and then down southward into West Texas, and seems to have a connection to this tropical plume that's coming across northwest Mexico ahead of this upper trough, which is evident by the open cellular convection around the Bight of California. So the circulation center is kind of straddling or stretched out from, the southern part of Nevada down to the Bight of California. This is a pretty impressive upper level trough. Aside from those weather features, it's a pretty nice day across much of the Great Lakes states, the high plains as well, southeast, also very warm down in Florida and Georgia. And then the Pacific Northwest is relatively storm-free at the time that we're talking. So here's Alicia Bentley's overview. I like to give this as an overview map of the current time. This is for 12Z. It's 6 hours old now. But the shading is the 250 millibar wind speeds. The dashed lines are thickness from 1,000 to 500. And when they turn red, you're above 546 decameters and higher. And then sea level pressure is in the black lines, and they're every 4 millibars. So here's our storm over maritime Canada. Has a pretty nicely structured warm front emanating to the east, and then the cold front stretching southward across New England, and then turning westward across the Ohio River Valley, and then another dip in the column average baroclinicity down into this upper trough, which is off the coast of California. And then downstream of that thickness trough is where we're beginning to see, only weakly at this stage, the development of a surface disturbance over New Mexico, western Texas. And over the Pacific, a pretty deep thermal trough, which will be mirrored in an upper level 500 millibar trough. And there's a cyclone sitting in the Gulf of Alaska. We'll go further west in a minute, and you'll see that it's a large collection of meridionally oriented cloud and moisture plumes in the central and eastern Pacific. So not well-organized cyclones per se. One other thing I wanted to show you about the impending trough here off the California coast can be illustrated by Alicia's standardized anomaly maps. This is the 500 millibar standardized anomalies of geopotential height. And this is valid also at, I guess I have it at the wrong time, but anyway, it's close. It's 6Z instead of 12Z. But you can see this trough off the California coast is quite anomalous. This is in the 3 standard deviation, the 3 sigma range for an unusual deep trough. And then the downstream ridge, surprisingly, is also a fairly impressive anomalous feature. It's a 2.5 almost, a 2 to 2.5 sigma feature over the western part of the Gulf of Mexico. So this combination is producing substantial anomalous southwesterly flow over the plains. And there's curvature in that flow. And so as we'll see, there's also shear because the speed change is substantial. We're going to find that there's sizable and well-organized forcing for vertical motions over the western plains or the eastern plains of Colorado and New Mexico and the panhandles of Oklahoma and Texas. So that's setting the stage for what's going to happen next. And then further upstream to the west, still fairly anomalous ridginess, not so anomalous troughiness. So the ridges are somewhat unusual, the troughs are not, but this is a really anomalous trough, and downstream of an anomalous ridge. So that's kind of a nice perspective to take on this situation. Okay, so here's the radar summary from this morning, ending about, I guess, 10:30 a.m. And you can see evidence of that trailing cold front from the storm in the Maritimes with precipitation echo even well offshore being evident south of Long Island Sound and south of the Massachusetts Island counties, and then across the central part of the mid-Atlantic states down through Kentucky. And then earlier this morning, this precipitation region over Kansas and Missouri was populated by considerably more, you might even see it at the beginning of this movie, considerably more frequent and more densely spaced cellular portions of pretty high convective activity. So I don't know any of the sensible weather that came out of that, but I would suspect there's probably a little bit of hail and maybe some local downpours associated with that weather over Kansas and parts of Missouri this morning. And then you can see the circulation center discernible even in the radar right here over the southern part of Nevada and western Arizona, and some open cellular type convection over the state of Arizona, northern Mexico, San Diego area, and then just to the west of the bight. So this is the upper trough of interest for what comes next in the weather across the central plains, or actually western plains of our country. Let's take a look now at the West Coast satellite image, which gives us another view of that feature off the coast. So this is a pretty impressive upper trough, and it's not surprising that it's almost a 3 sigma event. I think you'll see when we get to the 500 millibar maps that the temperatures are also really, really cold. And I didn't look at Alicia's standardized temperature at 500 millibars. It might not be one of the standard variables that she puts, but I'll bet it's at least a 3 sigma event for that latitude. But the presence of an upper trough down over Southern California in mid-March is far from unusual, in the sense that I think Los Angeles has its coldest month of the year at 850 millibars in March. And so that's a climatological norm for Los Angeles, just above the surface. And so troughiness in this region is not so unusual. This depth of troughiness is, and that's kind of what's interesting about how it sets up for a potential record snow just to its east later on in time. But here's the cloud streets that I was commenting on without you being able to see them earlier, and that is they're more or less north-south oriented. This one here at almost the date line stems clearly. Here's the state of Hawaii, which is sort of the northern boundary of the northern subtropics. And so this cloud street has its feet in at least the northern extent of the subtropics and goes all the way into the central Bering Sea and further north than that, perhaps. And then this one further to its east looks mostly meridional. It has a couple of little, sort of baroclinic leaf-looking structures to it. This one here off the coast of British Columbia, and then another one further south, closer to the island of Hawaii. This week in Hawaii, of course, there were flash floods. So this is the remnants of that disturbance which plagued the islands for much of this week. Maui had some really disastrous flooding and landslides and various other things. So this is maybe a little bit later in the year than normal for that. That's often a February phenomenon, not a March phenomenon. But something like this can happen in Hawaii at the end of the winter, as the winter is beginning to die down. One of the things that's kept me interested, and it shows up on this satellite picture as well, is the tendency for there to be substantial cold air outbreaks over the Gulf of Alaska this last several weeks. So there's been a lot of cold air built in Western Canada and over the state of Alaska, which of course is huge. It's 1/5 of the size of the continental 48 states. So it's not a small state. And so you can see some evidence of cold air disturbances or disturbances developing in the cold air that flows off this mini continent of Alaska. There's one right here in the northern Gulf of Alaska. It's quite nice. And then look at the stratocumulus that looks like smoke, probably even is sea smoke originally, right off the coast. This is a front edge of that next substantial cold outbreak that's flowing off of Alaska. So here's one other one that's a little bit older in vintage, but nonetheless, look at that open cellular convection at latitude, 38 degrees or something? So that's very cold air at upper levels. And it's been continuously happening, I think, the last 2 or 3 weeks, or nearly continuously. So, we had a big discussion in mid to late February about the cold air outbreak over the central US, and especially how hard it hit Texas. Cold air outbreaks can occur over the ocean too. And, one of the ways that the hemisphere sheds cold air is just by funneling it southward, and upper disturbances cut it off and bring it southward, and it moderates. But if it moderates, if it gets spilled southward over the ocean, of course, it moderates a lot faster and doesn't get anywhere near the profile of discussion that it does when it comes over land. So I've been reading a little bit recently about studies about cold air outbreaks. And one of the things that I notice is that it's so heavily biased toward cold air outbreaks over the land. And really, one ought to think about them as a general phenomena on the boundaries of the Arctic cold pool in the wintertime, not just when they occur over land. So there's probably something to be learned by doing so. So anyway, that's kind of interesting off of the coast of Alaska. Then let's go to the 500 millibar charts, or the 500 millibar chart. What's the matter? I can't get to that next one. All right, well, I guess I'll just have to do it manually. I'm not sure I understand what's going on there. I had it loaded in, so I'll just go to the observation maps, and I go to the super Pete's, aptly named because they were made by Pete, and Pete is super, so we put it together and we call them the super Pete's. Here's the 12Z 500 millibar map from this morning. And look at how cold it is off the bite, minus 32 degrees. That is really cold. And as I say, I'm guessing, but I'm going to guess that's about a 3 standard deviation anomaly at 500 millibars for the temperature. And this upper trough is really quite impressive, and very strong horizontal temperature contrast on its southern and southeastern side. And we don't have enough wind information in these observations to suggest that this is also a region of really strong shear, but I think that it is, and I'll have a little bit of evidence to point that out to you here in just a minute. So that's a pretty strong upper level front that is on the eastern vanguard of this upper trough, which is a fairly large upper trough. It encompasses most of California and Nevada combined. And those are not small states. So this is a pretty impressive, positively tilted upper broad long wave trough. And then within it, a pretty intense upper trough that we see about to wreak havoc over the plains. Here's that feature that was not so anomalous in the troughiness in the southern Gulf of Alaska, the 500 millibars, but it's quite cold. It's minus 40. So this is, and it's minus 40 over, the eastern half of the state of Alaska and in the Northwest Territories. That's cold. That's really cold. And so it's spilling out over the ocean, and that's a cold air outbreak. And it's just being modified and producing all kinds of sea smoke and open cellular convection and little disturbances that get organized by the slightest little region of curvature in the upper level flow. And we saw some evidence of that. If we'd had a really close-up satellite view of the northern Gulf of Alaska, I think there would have been populated with a whole bunch more features that would have been evident by eye.
John?
Meanwhile, yeah, go ahead, Michael.
Yeah, I was just curious. This is about the time of year for pretty great frequency of cutoffs over the southwestern United States. Is that correct?
It must be, because it's reflected in the cold climatology at Los Angeles. Yes, it must be. Yeah.
Right. So it's just interesting because it seemed back in the 80s and 90s, and again, this is fuzzy memory, but you'd see a lot of those. And then I would say in recent decades, it seems like it's been less apparent. I don't know if you get that sense.
I guess I don't know. This is where I would defer immediately to Angela, because if one knows a lot about convection in the Central Plains, and I think this is a setup this is the beginnings of the synoptic setup for
Right.
such a thing. Has that been the case, that we've had a little, less frequent setups along these lines? Do you have an instinct about that, Angela, or better than an instinct, maybe some direct sense of that?
I don't know if she's muted.
All right, I'm trying to find my unmute.
Oh.
Could you repeat that last question? Sorry, I didn't quite catch what you were asking me.
Yeah, I'm kind of asking, and this is in response to Michael's question to me, is this set up with an upper trough over Southern California, Northwest Mexico, and then a ridge over the Western Gulf of Mexico? That seems to me to be one that sets up the Central Plains for potential severe weather outbreaks. Is this kind of, Michael had the sense that maybe this structure is becoming a little less prevalent, and that's anecdotal, and I would have to agree that I don't have more than an anecdotal sense of that. And we were wondering if you had any statistical or empirical observations that would either confirm or refute that.
Yeah, I think that's a great question, John, and I actually can't answer that in terms of the statistical frequency, like say over the last decade of how of this setup. So I think that's a great question, and I don't have a short answer for that.
Okay, yeah, I wonder if that's a worthy question to pursue. One could do that with, a relative degree of ease, at least step into it, and then you'd have to really figure out what you're finding and make some sense of it. But yeah, so okay, that's good. I'm glad to know from an expert. That's an open question that's worthy of some investigation, Michael. So you got a good instinct on that. Look at this geopotential height just northwest of in the Bay of Campeche, 5920. And we saw that was almost a 3 sigma event. So this is a really striking example of this kind of a setup. And so we've got a sort of a 3 sigma-ish forcing for a strong southwesterly flow into the Central Plains of the United States. Perhaps it's not surprising that something of a 3 sigma type event might be the response to that. I guess that's one way to think of it. So I'm going to show you a little bit later some evidence of what might be forcing the vertical motion that's beginning to organize that cyclone. I think on Alicia's map, we saw that organizing over central New Mexico, and that's in the right place. It's downstream of the upper trough. And most of this trough is not so well resolved, as you can see, because at least most of the curved flow is offshore. And so we don't have the best resolution of any little individual wavelets that might be in there that could enhance or localize intense vertical motions. So I think I've been on the periphery of this discussion about this impending event in Colorado, but my sense is from that periphery that people have been saying it's been vacillating back and forth from a major event in the Denver metro area to one that's not so major and it's going to be focused somewhere else. So I wonder if some of that forecast sensitivity is either human induced. People live in Denver and Boulder and they'd really like to see this event. And so they get frustrated when one run doesn't show it. That could be it, could be just that. Or it could be really honest vacillation in the forecast. And as I say, I'm not equipped to tell which one it is because I haven't had my eye on that ball. So
I can comment a little bit on that.
Okay.
John. The forecasts around Denver and the Mountain West are highly dependent on the absolute wind direction because it's really about the slope flow. It's about how the wind blows relative to the mountains. And when you have these cutoffs like this, that really throws a monkey wrench into the forecast because just a slight shift in the cutoff, these squirrely winds, and the winds can switch from upslope to downslope. And and they just, if they just turn a little bit, even though a trough aloft may be fairly predictable, the winds at low levels can switch from being upslope to downslope just from subtle differences. Yeah. And I know when we were up in Steamboat, we'd get these cutoffs all the time. And you would think that predicting the snow on the western slopes would be easy because the mountains are there, you get westerly flow in the winter with the upper air and you're going to get snow. But this time of year, when you have the cutoffs, nope, sometimes you get easterly flow, sometimes you get southerly flow. Mm-hmm. And it just changes the forecast. In one case, you get nothing and it shifts a tiny amount and you get a ton of snow. Mm-hmm. So I think that's part of the problem.
I don't think I could live on that edge. That would be too much for me because if I was looking at a forecast in some of these places, 4 or 5 feet of snow, and then when you got 2 or 3 inches, I don't think I could take that. I'd probably find the tallest hill and just intentionally roll down in a way that would endanger my physical health.
In the current,
too much for me to take.
In the forecasts they're showing now, it's getting especially squirrely because they're having the low move kind of over eastern Colorado, so it's sitting maybe just south of Denver. Mm. And when you get those kind of situations, the flow is actually diverted a little bit because of the topography, and places like Fort Collins to the north will wind up with northerly flow coming over the Cheyenne Ridge, and they'll be in a shadow. Mm, and because they're in the shadow of the ridge, they may get no snow, whereas we've seen Fort Collins get nothing and Denver get several feet.
Yeah.
And this is a kind of situation that looks like it might be happening. The famous Colorado blizzard of the 70s was like that. And Fort Collins had nothing. In fact, Fort Collins is called by the department, the Chamber of Commerce, it's called the Choice City. And it was the Choice City because the Indians used to set up camp there for the winter because they would count on these shadowing effects of the Cheyenne Ridge to prevent them from getting the major storms.
Oh, how interesting. Yeah, how interesting. So Laramie gets it worse than them in such a situation.
Oh, Laramie is terrible.
Yeah,
Laramie is on I-80 to the north, and they get whiteouts all the time. People, it's unbelievable. You can't even get across.
Stories like that is enough to almost make me move to Wyoming, but I won't.
Well, that was sorry, just some context too. It makes me think of the 2003. That's what a lot of this is being compared to. And there was enough downsloping from the mountains, but there was like hardly anything in Boulder and Longmont. Yet Fort Collins had, several feet of snow. So it's such a nightmare. Yeah.
How interesting. Yeah, that is a nightmare, man. Yeah. Oh gosh, that's terrible. Let's take a look at a couple of other levels here. So that's the 500 millibar map. I'll go to 300 next. And so here's the 300 millibar map, and you can see a very wavy flow. And that's, I think this is, I'm not showing you the whole week, but we saw that in the week-long satellite. One gets the impression that this has been the case all week long. It's been a fairly high amplitude flow over us. And, that's part of the way you get to 61 on a couple of days in a row, and you don't really get very cold on one of those nights with a strong southwesterly flow. I think our minimum on Wednesday night or Thursday night was in the high 40s or low 50s, which is just unbelievable. So high amplitude flow continues. And as we already mentioned, this is a quite anomalous upper trough, and it's downstream of that you start to see development. And let's go to maybe 850 won't be very good for the region of interest particularly, but we can see around the rest of the country, we get a little bit of a picture of the cyclone over the Maritimes with a decent warm front. The cold front's a little bit washed out, and we saw in the satellite that it's a fairly continuous band, not the satellite, the radar, fairly continuous band of active precipitation all the way down to the panhandles of Oklahoma and Texas. And that's tied with this structure in here that's really hard to discern at 850 millibars with the way that this is analyzed. If I were analyzing, I might put my +10 isotherm up through Illinois and Indiana, because I don't have to put it right on the 10. The computer doesn't know better than that. And the 0 might also come a little bit further south. So I want to accent that baroclinic zone a little bit more, just because I see that it's active and it's likely to have some sort of dynamics tied to it. But here's our weak disturbance trying to get itself organized in the lower troposphere over Arizona at 850. And I think we saw at sea level, it was a little bit further to the east over Arizona, over New Mexico. So it's a complicated terrain, a complicated upper trough that's almost sort of on the straddling a short wave and a longer wave feature. So it's going to take some time to put that all together, it seems to me. And I've got,
John?
Yeah.
I was going to also say, just getting back to the eastern and central part of the United States, where you're just describing where that 10-degree isotherm would be. It's just a nice example of a broad region of confluence in the central U.S. all the way to the East Coast. You can see that southerly flow from the Gulf of Mexico across the south central United States, and then the more northwesterly flow over the Midwest into the toward the Mid-Atlantic, and everything kind of goes along. I don't know, it's probably what, 35 north or so.
Yeah, that's right. And look at the difference in the dew points. All you get here is the dew point depression, of course, but you got a 21 degree, 17, 16, 20 at Pittsburgh, 26 at Pittsburgh, and so on, 27 at near Detroit. Those are really dry air and the slight cold advection, and then moist air, 4 degree dew point depressions, 1, 2, 2. So this is air that's moisture laden and warm, and it's headed into the Central Plains and to its north, cooler, not downright colder, but cooler, but especially drier. If this were a theta E map, you'd see a much sharper gradient, and that would probably compel you to redo your theta analysis and make it look a little bit more impressive than it does in this first cut. So you're exactly right. And then on top of that, strong confluence from southwesterly flow over the Oklahoma all the way to Manette, and then northwesterly flow everywhere to the north of that, acting on top of that baroclinic zone. And there you go for producing your thermally direct frontal circulation, which in turn helps to explain that precipitation feature that's fairly continuous along that boundary. So the last thing I want to show is the QG vertical motions that are valid. This is from last night's GFS. So these will be valid this morning. This is at 700 millibars at 12Z. So yellow is ascending air, blue is descending air at 700 millibars, and it's about every centimeter per second. It's actually decipascals per second, but that's close to centimeters per second. And then the dotted lines are 500 to 900 millibar thicknesses. So you get an idea of what the thermal contrast is through the column. So here's the upper trough and the obvious ascent to its east and descent to its west associated with that feature. And the ascent's right over the Four Corners area, and that's about where we're seeing our surface / 850 geopotential height minimum start to organize. And it's organizing, it seems, in response to this kind of broadly distributed vertical motion plume at 700 millibars. And if you split that up a little bit, here's the part that is resulting from the PVA, NVA by the thermal wind. It's largely the whole picture. And that's the Sutcliffe-Trenberth omega at 700 millibars. And the other piece is the transverse part of the QG omega. That is the part that's tied to, as best as the QG system can do it, frontal circulations. And you can kind of see couplets that straddle the baroclinic zone all over the place. Here's one over New England. Here's one over maritime Canada. Here's one along that long baroclinic zone off the Pacific coast. But there's no such couplet associated with our upper trough. So to the extent that this thing is still getting itself organized, the thermal structure is not yet producing couplets of vertical motion that resemble frontal circulations. That's not its main situation at the present time. And so going back to the Sutcliffe-Trenberth, this is the vorticity advection by the thermal wind. And it's sometimes interesting to split the vorticity into its shear and curvature components just to see how they split up. So this is all the vorticity being advected by the thermal wind. This is the shear vorticity being advected by the thermal wind, and that gives a pretty decent couplet of ascent in yellow, descent in blue here, right around the Four Corners area. So the shear vorticity is a serious contributor to the total forcing for vertical motion. The curvature vorticity is got a whole different complexion to it. On the descent side, it looks about the same in terms of its intensity and maybe even its distribution as the shear vorticity descent. But on the ascent side, it's not as strong. It's more widely distributed, and it's got this funny little feature down in northern Mexico, which probably is a function of just some local curvature in the flow from the model. But this doesn't look like it contributes quite as much. It certainly reinforces what's going on with the shear vorticity advection. But I think the shear vorticity advection, at least through 12Z this morning, of the two, is more likely to be concentrating the ascent. And that might be why we see at 850 millibars, which is effectively surface level over northern Arizona, that's where the cyclone's beginning to take shape, is because that's the column of air that's most dramatically being stretched, and you're starting to have a response in the circulation at low levels, and that in turn induces a geopotential height minimum. So that, I don't want to say more about this thing because I think the exciting stuff comes in the forecast, but this partition is somewhat unusual in the sense that it's not often that the shear vorticity advection seems to play a slightly more dominant role than the curvature vorticity advection, although, and I don't know what the physical meaning of that, if there even is any to it. It's just that it's unusual and therefore worthy of note. And this is going to be a notable event, so maybe it's getting off to a somewhat notable start. So that's all I have. I'd be happy to entertain any questions or comments, but if not, Angela's got some things to talk about from convection from this week that we'd like to have. So I'll stop sharing.
All right, let me share my screen. Oops. Are you able to see that?
Yeah.
All right. So I'm going to talk about convection, but before I talk about deep convection, I want to point out something that we've been talking a whole lot about in class with lake effect clouds. So this is the current satellite loop, and this is kind of a classic example of what we've been talking about, looking at the short parallel rolls moving off Lake Superior. So this was just something we commonly are talking about and seeing this winter. I wanted to show just yet another example today. And if we look at the current radar for Marquette, you see that indeed quite a few of these are precipitating just east of the Marquette area. So this is a classic example that we've been referring to, and I wanted to point that out. And if we look at the surface map, as expected, it's occurring behind this cold front, and you can see the northeasterly winds that are roughly perpendicular to the major axis of Lake Superior. So that's just a shout out to the 453, 753 class, as we've been talking about this considerably. But if we go back to the satellite image, you see this swath of snowfall over Minnesota. And so this was from a few days ago where there was a winter storm warning in this section of Minnesota. And to the south, we had the first severe and tornado warnings of the season over Minnesota. So I just want to take a little bit of time to go over that event. And what was notable about this event was the production of hail. So just south of Minneapolis, St. Paul, you can see up to 2-inch hail fell over this region. And the storm reports you can see were largely concentrated in that area, including the largest hail report from SPC of 2.5 inches within that region. So that's denoted here by the triangles for the hail reports that are greater than 2 inches of diameter. So there was a lot of hail that was reported roughly between 2230 and 2330 over this region. And if we look at the actual forecast from SPC, you can see that there was a slight risk for severe weather, and in particular, greater than 15% chance of hail for this region, forecasted to be between this time about 4 to 8 p.m. And also notable, there was a tornado watch issued extending from about 2:40 p.m. through about 8 p.m. So a pretty large period of time. And the first tornado warning, which ended up being radar indicated through the velocity couplet, was first issued at about 4:45 or 22:45 UTC. So as the hail producing storms were being formed, there was a few that showed signs of rotation that had a tornado warning. And what we talked about in 453 lab for this case is the students pointed out that there was record-breaking high temperatures in this region earlier on in the day. So it's really highlighting kind of the unusual event that took place. And I was curious how unusual this was in terms of severe thunderstorm or tornado warnings for this time of year. So what this is showing, I got this from the Weather Service in Twin Cities. It goes back to 1985 up until this year. And it's the average start, or it's the start dates. You can see the start date and the end date of this severe thunderstorm warning, and the color codes is the daily count. So how many warnings were issued for severe thunderstorms for a given day in each year. So just broadly point out, with the exception of 2017, this was the earliest severe thunderstorm warning in this weather forecasting office region. And then in terms of tornado warning, same story, with the exception of 2017, this was the earliest tornado warning that was issued since 1985 for this region. So if we just very briefly look at the setup that was in place, you can see in the surface map here, the low pressure system that was situated over Western Iowa. And associated with that, the cold front stretched down through Nebraska into Kansas, and then we have the warm front that was situated moving into southern Minnesota. So what this shows here, this is from the Storm Prediction Center's mesoscale discussion. And so they issued this mesoscale discussion that shows this region here, the orange contours are Cape, and you see the low pressure system situated here, and then the wind barbs are the bulk shears. So this is a situation where this area is highlighted as a region as the warm front moves through with sufficient bulk layer shear over the 0 to 6 kilometer layer. So out ahead, so associated with that warm front that was moving through, you can see the high theta E moving into this region associated with the southerly flow behind the warm front. And if we look at surface-based Cape, most of that is concentrated in eastern Iowa or western Iowa. And you can see the surface-based SIN shaded here over the region. So this is suggesting that things that were going to be initially forming out ahead of the front would initially largely be elevated. And then there was a sufficient cap that was associated in eastern Iowa, and most of the Cape was elevated. Whoops, went too fast. If we go up to 500 millibars, here you can see largely where that shear is coming from. You've got the trough that was moving through, and then you've got the strong southwesterly flow on the loft. I'm going through this kind of quickly in respect of time, but here's what I really want to show is, so we had the strong surface heating ahead of the surface low in the cold front. There was strong southerly flow behind the warm front that was increasing the moisture. And we could see some elevated convection that was forming earlier in the day. So for context, this was a couple hours before the severe weather reports in southern Minnesota. And so you can see this region of clearing behind the front. So this is where a lot of the early convection was being initiated. But there's some broken clouds here in southern Minnesota that ended up being really important in the destabilization over the next few hours. Another thing to point out in addition to the shears, there were steep mid-level lapse rates. As I mentioned, this was initially pretty elevated convection. And if we go to the Minneapolis sounding, so this was early, this was 12Z in the morning, this was in the morning. You can see these steep mid-level lapse rates above 700 millibars. You can see the strong surface inversion earlier in the day. So the 0Z sounding was actually taken through a lot of the precipitation, but again, the mid-level lapse rates continue to steepen throughout the day. And indeed, this was supportive of the hail that I mentioned had been produced. So I want to show now the satellite imagery from GOES East, and there was the mesoscale sector was situated over this region in anticipation of this being a severe weather event. So this is 1 minute GOES imagery from 20 to 23 UTC. So this encompasses some of the first hail reports. And you can see the overshooting tops. This 1 minute imagery is absolutely phenomenal. And you can see the deep convection that had formed in that area just ahead of the front where some of the broken clouds had occurred earlier in the day. I had to zoom in on this because you can see the rotation in this storm around between 2230 and 2300 UTC, and these storm tops were up to 12 plus kilometers, these that were producing the hail. So this was kind of the first really cool 1 minute imagery of some rotating storms in the mesoscale sectors for this year, which was really cool to see. And just very briefly to tie this into things here at UW-Madison is SACC's Prob Severe. So we briefly mentioned this the last time I talked about hail from the last event, and I'm not gonna, we don't have time to go through all of the parameters that go into it. But from this snapshot of this particular deep rotating storm, there was a relatively elevated higher probability of severe weather. You can see that marked here in terms of hail and the possibility of a tornado. And this was the one that had the velocity couplet at the near the low levels from the radar data, but there was no confirmed tornado reports, just the large hail that was observed. And then similarly, if we jump ahead an hour to when that hail was observed, Prob Severe indeed had a 16 to 20% probability associated with the storm at that time of the hail formation. And for those in 453, 753, we're going to go into this a lot more detail when we get to the hail section. And very quickly, I want to show the radar loop for this period. So this is a 6-hour radar loop. Let me actually start back at the beginning. So you can see the scattered convection that it initially formed earlier in the evening. And these most intense storms, let me go back, around this time ended up being the ones that were warned that eventually produced the hail. But you'll notice as that front moved through, the wind profile ended up becoming more unidirectional and oriented along the front. And you see it became more linear in features rather than discrete as it moved on later on into the evening into Wisconsin. So in the interest of time, I just want to that was just a really exciting, it was kind of the first Upper Midwest case. It was, besides 2017, it was kind of unusually early to see that. So that was something I thought was pretty notable, as other parts of Minnesota was under a winter storm warning behind the front at the same time. So today, let me go to today that the convection that John mentioned in Kansas is out ahead of this warm front. But one of the things to note here is this dry line set up over eastern New Mexico. And really this area, this intersection of between the dry line and this warm front is a notable area today for potential severe weather over the Texas Panhandle into Oklahoma. So not surprisingly, there's a slight risk for this region issued by the Storm Prediction Center. If we look at the Amarillo sounding from this morning, again, we have some nice steep mid-level lapse rates. And there's quite a bit of low-level shear associated with this event too. So we may see some supercells today over the Texas Panhandle. If we look at the surface obs, you can see there's high dew points in the 60s from the southerly flow into this region. Behind that, behind the dry line, you can see the really cold or the really dry air. So this is the region that we want to be looking for today for convective initiation. And this is a region you can see surface frontogenesis from this mesoscale analysis from the Storm Prediction Center. As I mentioned before, we want to really keep an eye on this intersection between the dry line and the warm front for initiation. And then if we look at the potential for hail, here you can see the cape between -10 and -30 C. It's also quite high in this region. So it's just a consequence of that steep mid-level lapse rate. So in consideration of time, the long story short, supercells with the potential for hail and maybe a few tornadoes in the Texas Panhandle into Oklahoma. So that's kind of the convective story from the past few days and looking forward to today. I will hand it over to Michael now.
Thank you, Angela. And I'll just get this started up. Okay. Good morning, everyone. We'll first take a quick look at a couple of meteorograms. Again, I always like to do that. And you can see just basically for a quick look at the weather ahead coming up for this weekend. Pretty nice weekend. It's certainly going to be dry. We can't say anything about cloud cover just yet, but temperatures moderating tomorrow, getting a little bit warmer. And then we see that there's a decline in the temperatures as we get into Sunday, and we'll see what that's associated with. We'll also take a very quick look at our time height section, and you can see the dynamical tropopause is rather high. No really significant tropopause undulations over us. Again, those are the green lines here, and you can see they're really, probably at its, close to where typically the tropopause would lie, around 300 millibars or a little bit higher. In yellow are the isotropes, and again, you can see the formation of a fairly decent mix layer, at least within the context of this model, that forms during the course of the afternoon with potential temperatures nearly uniform with height. And then similarly, tomorrow, same thing happens, and you can also note that when we mix up to about 279 today, tomorrow it's about 6 degrees warmer in terms of degrees Celsius. So tomorrow will certainly be a warmer day, and perhaps getting into the 50s during the day. But then, if you look carefully at the winds, we get some westerly winds tomorrow. Things begin to warm up. There's subsidence in the column over us, and as you look carefully at the wind direction tomorrow and tomorrow evening, winds are westerly, northwesterly, and then they kind of abruptly switch from northwesterly and northerly to more out of the northeast, and are backing with increasing height, and that indicates cold advection in the lower part of the troposphere. So we're going to get cold advection out of the northeast, which is going to cool us down for the week ahead. And that's largely due to a building anti-cyclone over eastern and central Canada that's going to build slowly southward and eastward over time and bring our temperatures back to a more chillier weather regime. And so we'll see how that looks. But before I go to the current forecast, I want to look at another so-called meteogram. This is John's. This is from the ECWF. They actually allow you to produce these forecast plumes. This is from the ECWF site, and this is just looking at the week ahead. And this is from their ensemble prediction system. One of the themes of the discussions I've been trying to lead during the Weather Watch this semester has been looking at sort of notions of predictability and different measures of it. And this is a forecast plume that originates from last night's run of the ECWF model. ECWF has 50 members in it, and they're also showing a couple of the members. There's the mean. The control run is the solid line, and the heavy dash line is one of the high resolution runs. But the others are ensemble members, or the dashed ones, excuse me. And you can see, you could view the spread in these forecasts, and I don't know if they've been post-processed, so my apologies there. The spread indicates sort of some measure of certainty. The more closely contained the forecast plume is, the more likely you have a sense of where what the forecast is going to be, and the broader it gets out, the more uncertainty in the forecast. You can expect that forecast uncertainty will grow with time. And you can see for Madison, today's being a little bit, tomorrow being warmer than today, and then that decrease in temperature over time, with the mean actually, temperatures during the day getting into just the middle, just the mid 30s, just around freezing or slightly above freezing during that time period. And then you can see a fairly cold period, and then eventually beginning to warm up as we get into the beginning of the following week, not next week, but the week after. For precipitation, again, a wet period, perhaps starting during, it suggests, some precipitation on Saturday. I don't think we're going to see any evidence of that. Let me make sure I'm actually looking at the right. My apologies. Total apologies here. Let me go back to Madison. We were looking at actually Colorado, and that's why I was looking, that's kind of odd for the temperatures. Thought they had updated this. This is for Boulder, Colorado. So warm day there for day, and then this is their period of snow that they're expecting. Again, you can see the forecast uncertainty growing. We'll compare that for Madison in just a moment. So it says precipitation, geopotential dropping sharply as that upper trough moves over there. We'll be looking at the forecast for the Western United States in a few moments. But for Madison, yes, please.
In this spot here on the top, the temperature at 850 map, on Friday the 19th, what's this white area? How does that get determined that that's not part of the colored in 0.5 to 1 to 10%?
So I guess because if you look, the ensemble members, there's not a single ensemble member that passes kind of through this region.
Okay.
So you can see their ensemble members down here and up here, and I guess the clustering of them, this is where they've done some post-processing to fill that in.
Okay.
I guess that,
Okay, thanks. That's sensible.
Mhm.
Can you scroll up to the geopotential at 500 millibar? There's a cleft on the 20th where a trajectory does go through there and it's colored in white. So this might just be a threshold interval problem or something like that.
that could very well be.
Okay.
This is, I was looking today for different products and I came across this, which is interesting. And again, my apologies to everyone starting out thinking this was Madison. No, and you're right. I should describe what we're looking at. This is geopotential at 500. We have the precipitation and the 850 temperatures. And now we're going to shift to Madison. So you can see just a difference in some of that. This is Madison. There's the increase of temperature, tomorrow relative to today, and then temperatures dropping off significantly. With our staying basically, Monday and Tuesday, perhaps below freezing, warming up a little bit on Wednesday, getting into the low 40s. And then we sort of see a collapse in temperatures beyond that, with temperatures kind of staying in the 30s into next week. And that's, as I was describing this earlier, I think the forecast is updated. No, that hasn't been updated yet. This is just I had the wrong city. Oh, my apologies on that. And then we get to the ensemble forecast. This is for precipitation. There's our event. That'll be from the western United States. This is the potential for some snow and rain, maybe some freezing drizzle as well, see in the forecast. And then another potential weather event midweek. And so we'll kind of look at where the origins of that. And then geopotential again. And so again, that was 850 temperatures we're looking at. Geopotential again, we can see sort of the drop in geopotential heights over us. This is, I don't think, a particularly interesting set of numbers to look at. But again, you can sort of see the variability in the forecast as we get out to longer lead times. So returning to our MM5 forecast, first thing I want to look at is the evolution of the potential vorticity over on the 310 isentropic surface. And you can see where they're outcropping these plus signs right here, just where the isentropic surface intersects topography. But you can see at this level, that broad upper trough that John had described nicely off the west coast of the United States. If we were to go cross section through this, we would see a cold pool beneath it. And this often brings showery precipitation once it moves on shore to parts of Southern California. And that's kind of even post-frontal. So they get almost all of their interesting weather at times out over the west coast. And we're going to look at the evolution of this feature in the forecast. Well, let's begin the animation. And you can see that really robust cutoff just moves on shore across the Four Corners region, then across the southern parts of Colorado during this time period. And you can see largely the precipitation, there's conservation that you can see here, but you also see this band of low PV that emerges. I'll stop this and just point it out, that emerges over Kansas and Nebraska, and that's evidence of some significant diabatic heating. So what am I looking at? I look at the PV in this region over parts of Kansas and Nebraska. You can see the colors here. You have the light blue, and then it gets slightly darker blue. Again, here's the legend at the bottom, the legend of the PV, and we'll see as we go forward. That was at 42 hours. Let's go to 48. You can see this little purple area that just pops up there. Okay, and so again, if it were purely advective, it was perfectly conserved, we wouldn't see that. I think I may have lost the time. Yeah. Let me go back. Because around this time period, we see these purple regions that show up. There we go. Right. So this is going to be a region where we're going to expect to see precipitation. It was actually in the middle of the forecast period at 30 hours. Again, if I go back, 24, you can see this little purple area here. But those weren't there at earlier times. So you can't get those features purely by advection is the point. If we go look at the precipitation, we'll first look at the evolution of the surface map. And you can see really, really heavy precipitation. In fact, some perhaps deep convection that occurs just to the east of the Texas Panhandle in this region of instability that Professor Rao was talking about earlier. And this is actually during the period tomorrow. But with that deep convection, that's going to lead to potential vorticity redistribution. That's going to lead to increasing PV at low levels and decreasing PV above the region of maximum heating. And I believe that's what we're seeing some evidence for in the forecast. Furthermore, look at the push of the precipitation back in the northern half of Colorado up against the Rocky Mountains. You can see there's going to be significant precipitation forecast by this model over this region. As the upper trough begins to interact with the baroclinic zone to its east, you can see a nice creation of a thermal ridge. And this is also referred to as a trowel. And we'll actually see some evidence of that creeping over us during the forecast period over the week, early next week, when that precipitation eventually reaches our region by Monday afternoon. The other thing to note in the sea level pressure field is this anti-cyclone that develops in north central Canada. And you can see it moving southward, and pressure is beginning to increase. That turns our winds to the northeast, and that begins to cool us off over the period. And you can see that in the animation as this anticyclone moves southward. And that kind of, if you will, protects us effectively from getting much precipitation over the weekend. So next, what I'd like to do is look at a couple of cross sections in the forecast. And so this is a cross section taken. You can see sort of the center of the cross section. This is the Colorado Rockies. This is roughly the latitude just south of Boulder, probably between Boulder and Denver, this cross section. And what's shown on this particular map is the wind in the plane of the cross section. Negative values here indicate a flow from right to left. In this case, since this is nearly a zonal cross section, this is an easterly flow. And you can see an easterly flow of about 20 to 25 knots out of the east, impinging upon this topography and slowly ascending. You can see this cold pool also at the surface with the easterly flow. And this is part of the reason that they may be expecting first just precipitation in general, this upslope, this gentle slope from Kansas all the way up to get into Colorado. And then you get into the foothills of the Rockies out in the central portion of this particular diagram. If you look at relative humidity and vertical motion, let's look at that. And we can also animate this. And this is a cross section taken to give you the time. This is 24 hours. This is tomorrow morning, just as I think the event is going to be beginning. So vertical motion, positive or negative values here of omega indicate the upward motion, and we'll just step forward in time from tomorrow morning. This is updates. Again, vertical motion just blossom really quickly in this region. You can see the relative humidity is in green as well. So it's saturated. You have upward vertical motion. This is going to give you, again, we're going to give rise to that significant precipitation at these elevations. So this is the beginning of that snow event in this particular region. Now, one of the interesting things last night, I guess the 18Z run of the GFS, which has been extremely wet, anomalously wet, had effectively snowfall amounts that range anywhere from just a couple inches up to 94 inches for parts of northern and central Colorado, which is just obscene. I think the official forecast, we can take a look at that, is amounts probably 2 to 3 feet perhaps, and that was as of earlier this morning. That may have backed off a little bit, as we'll see in the forecast. But there's that, again, the same cross section. See the vertical motions beginning to diminish as we get into later tomorrow afternoon. But a persistent easterly flow is going to give a prolonged period of at least 36 hours of some pretty intense snowfall. And then eventually this begins to die out as the cyclone begins to lift out to the east. Again, if there are questions, please jump in or comment. At the surface, just to give a different perspective from a different model. Again, this is tomorrow morning at 12Z tomorrow morning. We can look at the location of the surface cyclone. Again, you can see this geostrophic flow. Again, this is not really geostrophic because we're not really at the surface. And this is the surface sea level pressure isobars, but we know that the topography isn't flat here. But there's that evidence of the easterly flow as it's developing. If you cut across a lot of the models, you can see the precipitation beginning in that thermal ridge that's being created with the warm advection into it. I'm just going to drift across these. But it doesn't look all that impressive tomorrow morning. And I'm wondering, for folks that have gone to school out in Colorado and want to speak to that, and I look at these maps tomorrow morning, and I'm not particularly excited about about the event at this point. But as we saw in the GFS and also in the MM5, we see that precipitation rapidly begins to blossom over parts of the eastern, the plains, all the way up to the edge of the mountains. by tomorrow afternoon. Look at that. But again, different configurations here are giving slightly different solutions, but it doesn't look like it's necessarily a blockbuster storm, but certainly a significant one in terms of the precipitation. So snow and wind, and a lot of these have the cyclone remaining just in the southeast corner of Colorado or even in the Texas Panhandle at this time. Go ahead. Yeah.
There was a comment in the chat. Kari asked, based on the cross sections you were looking at, can we say there is influences of gravity waves in Colorado?
I would say that's probably the case, but let me go back to the cross section. I didn't see that. That's a great question. I mean, the fact that we see this vertical motion pattern in the isotropes, we don't see much evidence, but you can also see that these layers are fairly weakly stratified. If I'm looking at let me make sure I have the right, this is theta E here, it's not theta. But let me get theta in the cross section so we can talk about that. And Greg is Greg and Angela, if you want to comment about the possibility of gravity waves. I mean, the stratification here is relatively weak, so I'm not sure if there's significant, I mean, there's certainly going to be gravity waves anytime the flow is evolving this dramatically. I'll go back to tomorrow morning. These spikes, I mean, some of this might be I think, surely due to convection, but this dark blue right here is just potential cyclonic PV. That's not going to be a gravity wave signature. I don't know if just looking at this, I could see significant evidence of it unless you're looking at the rippling of the tropopause. Greg, do you have a comment on that?
Yeah, am I on here? Yeah. There's not going to be gravity waves in the sense of downslope windstorms,
right?
Because the air's not moving across the mountains in that direction.
Mm-hmm.
However, there is a tropical plume over this from the south before the lull really sets up very much, and so in the early stages, it looks like there's a lot of gravity waves, but it's simply because the inertial frequency is so small that the geostrophic component of the wind is weakened tremendously. It just can't adjust. And so it looks like there's going to be a lot of gravity waves kind of with wave fronts moving from the southwest toward the northeast in that sense. And these are not generated by the topography. These are just generated by the large scale winds breaking up with low inertial frequency and inability to become geostrophic. But very quickly, as the storm spins up by tomorrow or so, it becomes very inertially stable again. So in the early phases of the storm, there might be a lot of gravity waves and thunderstorms, but I think as it spins up, the inertial frequency is going to become very high and very stable in that sense. I think there still could be embedded convection,
right?
But it doesn't look like gravity waves later on and during the real intense part of the storm.
Thanks, Greg. If we look at the evolution of the storm in the forecast, I'm just going to switch to just a single model for times. I know we're running late. And here's the cyclone on Sunday, late Saturday evening. Again, we're still high and dry weather-wise. By Sunday morning, cyclone is still producing. This forecast is still producing some snow in parts of Colorado, but you can see that the heaviest precipitation is actually well north of this cyclone center. Go to 60 hours in the forecast. The cyclone itself isn't that impressive. It's a broad cyclonic circulation, but I think this plume, this thermal ridge that's been created, you can see it in the thickness patterns right here. All this precipitation along in this region is associated with, if you're looking at it from a quasi-strophic diagnostic like the Q vector, it's these Q vectors are converging into the trowel, into this warm area, and you have this lift that John has described so nicely in his work. So this is going to be an area of extensive precipitation, and I'll show you one quick cross section through it. Let me get out of this. So the precipitation finally arrives in the form of snow on Monday morning. If you're not looking forward to snow, well, unfortunately, we're going to get it. And I guess you could blame John, and John will, I think, accept that blame. Is that correct?
That is correct. I will accept it with magnanimity.
Okay. here's the cross section, going from A to B. You can see the orientation of it. It cuts right through the precipitation just as it's arriving in the Madison area. I think, John, this is probably a very nice example. Here's the vertical motion. Here's the trowel structure, correct?
Yeah, it's pretty good. I mean, for the way these this gridded data tends to draw them, it's a really good one. Yep, it sure looks good.
And you can see this in the southern portion of this. Again, this is that thermal ridge we're referring to. Liquid precipitation. Once we get cold enough, it turns into snow, and it's going to be just on our doorstep during this time period. But it's also interesting to see how this begins to fizzle out. The kind of cross section is not moving, but it's that band is moving further and further to the north. The ascent gets weaker with time, and so will the precipitation. In the forecast, if you look at soundings, the most likely precipitation amount, and I'm not a big precipitation process person, but it goes from snow being likely to maybe freezing drizzle as the vertical motion, I guess, weaken a bit. And so that's maybe consistent with, well, here's this trowel pattern beginning to weaken as this disturbance moves to our north. And then by this time, you can hardly see any evidence of it. If I were to go back to these Q vectors in the forecast, again, it looks like a messy pattern, but you can see this thermal ridge, and you can see the Q vector convergence into it. I'll go to 60 hours where it's, I think that was a nicer time. Yeah, there's that nice thermal ridge, the trowel. And if you look at the Q vector convergence in here, that sort of supports the vertical motion that you'd be anticipating. So that'll come through our area during the day on Monday, and you can see the precipitation there and also see the decrease in intensity. If I were to do just a quick sounding through that. At this time, they're saying the most likely precipitation over Madison being snow. It's also interesting that some dry air has gotten in as well, which has weakened that precipitation. One thing about using these online things, you have to avoid the ads. And this is just a little bit later. It still says snow, but I had seen, I know, an earlier time period where it actually went to freezing drizzle. So don't see that happening here. Yeah, there we go. This is by Monday evening, the most likely type of precipitation is freezing drizzle. I mean, the entire column is below freezing, but I know we saw at this time that the forcing for ascent had weakened by this particular time. And then I'll just go back to a map and to finish this off, looking at the forecast going forward. Close this out for the rest of the week, and I'll just go in very broad chunks. This is on Tuesday morning. The cyclone is finally behind us, and we get into a brief quiet period before the next major precipitation event occurs. As this second cyclone, pretty robust one, goes by us, but it looks like it's going to be the heaviest precipitation is going to be south of us over Chicago. East WF is a little bit more generous with precipitation, but this is going to be, if this verifies, would be generally to our south. And the thicknesses remain low, so this is going to be a rather chilly period coming up beyond this. The only good thing to look at in the forecast is beyond the short-term period. Here's the CPC Outlook that came out yesterday for the next 6 to 10 days. Kind of chilly over much of the central part of the United States. And maybe that's also influenced by the heavy snow cover they're going to be digging out of in the forecast. But beyond that, we begin to go above normal for the west and the north central part of the United States, including us. So that's at least a positive thing coming forward. And in terms of probably as precipitation, dry over that 6 to 10 day period, and then continue dry or likely to be dry after that. So cooler weather, not as warm as we saw earlier this week and late last weekend, but and some more snow coming up, at least in the short term. And I guess that's it for today. Thank you, John. Thank you, Angela. Great presentations, discussion of the severe weather. And if there are any questions, we have a little bit of time to discuss.
Thanks, Michael. That was really good. Yeah, this has been a dry late winter, early spring, and it looks like it's going to continue for at least 2 more weeks. It's kind of unusual in that regard.
Yeah,
I guess
definitely.
I think that's good for the farmers because the snow, we had snow cover every day, an inch of snow or more from December 11th all the way until March 10th. So in Madison anyway. So I suppose the ground was not really being starved of water vapor and liquid water. So we should be pretty good for the beginning of planting season. The way things.
I wonder with the insulation of the snow the snow cover, prolonged snow cover, does that mean that the freezing depth didn't get as deep?
Yeah, it probably did, and that probably means it retained some liquid water too, which is great because now with it open and not any particular precipitation coming along before the ground gets plowed, I think it's probably perfect conditions. I wish I knew more about that, but it might be really good conditions for the spring.
Right, and also I guess maybe planting, if conditions permit, planting a little bit earlier, seeds germinating earlier because the soil isn't as cold. So
yeah, that's right.
I want to point out one thing before we cut off, that this event in Colorado is not unprecedented, but it's about a 10-year event. And I can think back of watching these things for the last 50 years or so. And there's been about 5 or 6 in the last 50 years of these kind of events. And when they happen, it's typical for the Front Range to get on the order of 30 to 36 inches. But when you get up into the mountains and the foothills, they can get the 50 to 60 to 70 inches. Man. And people live up there like I did. And when that happens, it's very interesting because usually you lose power for days. And it brings down the lines, everything, and nobody can get you out. Even the snow is so heavy because it's so wet that even the equipment that clears out the Continental Divide usually can't make it up in the foothills. So they don't clear out the roads, and you're pretty much stranded without power up there when you live up there for 3-4 days up to maybe a week. And what you do when you see one of these storms coming is you fill up your bathtubs, and that's so you can flush your toilets, because your well pumps all work on electricity. You're going to lose that, and it. So people right now are filling their bathtubs. Here it comes.
Except for the people who just moved there for the first time in the last 10 years.
And they'll be unpleasantly surprised.
Right. That's right.
You want to comment on the amounts? This is through Monday morning. Again, you can see Eastern WF's forecasted. Again, these are just 10-to-1 ratios. Around 20 inches or so. The Canadian model 25, maybe. On average. Then you get to the GFS, which has somewhere in this. I guess this is Fort Collins right here. A little over 70.
Yeah, that's where I live.
Unbelievable.
And that happens. It's and the thing about this is remember, these mountains are small scale. They're not resolved by these models. So right. The foothills where people live, the individual peaks, have various ways they funnel the flow and channel the flow. And I think with the kind of moisture that's coming in here, there certainly will be some reports over 50 inches and quite possibly up to 100 inches. Wow. In foothills that are only like 10, 15 miles from town.
Well, it's going to be an incredible storm. But I'm wondering, the variability in the peaks when you get beyond the foothills further into the real mountains. I mean, there's this broad area of ascent because of sloping terrain from Kansas all the way up until you get to the Rocky Mountains. So why isn't this? I know you mentioned wind direction is going to be really key to this, but if you get the basic wind direction right, well, if you get it right, then you get it right. I mean, you're going to get it, but how sensitive is it to a 10 or 15 degree change in wind direction, or is it the smaller topographical features like the Palmer Divide and the things
well,
sort of
the biggest amounts are very susceptible or sensitive for one of the reasons. I can't go over the topography right now, but if you look at the topography around Fort Collins, there's river valleys that funnel out toward the southeast, and the natural effect is with these triangular valleys that go up toward a ridge. When the flow comes in from the southeast, it'll funnel up these valleys and be focused on a particular ridge on the end of the valley. And this is not as true in the Continental Divide because you're above all that focusing effect and that channeling effect, and the flow just comes in straight from the east. You rarely see a snowfall of the magnitudes that you can get on the Front Range up at the top of the Continental Divide. There's less moisture up there, and the effects of the topography funneling the flow and channeling it are less. So these kind of storms produce, I think, the heaviest snow in the Rockies, compared to maybe heavy snow over the period of a season up on the Continental Divide. There are certain Continental Divide areas that get a lot of snow, and that's up by Steamboat Springs and Buffalo Pass or to the south. And those are affected by how much the flow has gone over ridges to the west, like on the Sierras. The Sierras steal some snow off the flow, and then the Wasatch Mountains in Utah steal some moisture, and then what's left will go to Colorado for the high mountains. But rarely does that flow like that come from the east through such a deep layer to hit the very high mountains from the east. That's pretty unusual. The flow up there is at 700 millibars. You'd have to have a cutoff all the way up to 500 millibars moving flow from the east to really get it up to the high mountains.
All right. Thanks, Greg.
Mm-hmm.
Any other comments, questions? Again, John, Angela, thank you, and Pete for getting everything set up. And
Thank you,
folks for
Michael. Thank
participating.
you.